This table summarizes some of the technologies and their capabilities. And here we look at 3G, RF mesh, and PLC. So let's look at them one at a time. 3G is an operator-managed wide area network, and it is based on licensed spectrum. It can support data rates up to 1 megabit per second, and it has a message latency lower than 1 second. Currently, 3G is covering more than 98% of the U.S. population, and in a 3G network, each cell site can have a range of tens of meters and up to tens of kilometers. And reliability today is at around 99%. And next, RF mesh. RF mesh is deployed and operated mostly by the utilities, and it uses unlicensed spectrum, mostly in the 900 megahertz today. It supports data rates up to around 100 kilobits per second, and it can support a message latency of about 1 to 60 seconds, depending on the network topology. Each node has a range of about 50 meters, but it can still be used to support wide area coverage using the mesh network topology. Reliability as well as latencies are highly dependent on the network topology and the specific deployment scenario. Then let's go to PLC. PLC is not a wireless technology itself. It is using power line as the communication medium, and it can generally support 100 kilobit per second of data rate with latency below 1 second. Depending on the specific technology that you use, it can support long communication range. However, there is a trade-off that the longer the range is, the lower the data rate will become. And all three of these technologies have certain built-in security features, and application layer security can be added in order to support SmartGrid's use case requirements. This table summarizes some of the key technology selection considerations. We have looked into a number of them, including ease of network deployment and operation, technology lifetime, capacity and performance, interference with other networks, and also the availability of other services. Let's go over them one row at a time. 3G networks are deployed and operated by the cellular operators, and there is a strong ecosystem in place, so there will be availability of low-cost devices, services, and also infrastructure. For both network and PLC, the utilities are responsible for the deployment and maintenance of the network. And in terms of technology lifetime, 3G is a very mature technology with over 300 networks worldwide. It is still being deployed in many markets all over the world. As of RF mesh, it is a new technology with limited vendor support. Today, it is mostly a proprietary point solution with limited use cases. PLC has been gaining traction in some areas, for example, in Europe and in some parts of Asia. But the long-term outlook of PLC depends on the traction that it can get in US and worldwide. Next, capacity and performance. 3G can support high capacity and data rate. Today, you can get 2 megabit per second or higher in many locations in US. It also can support superior latency performance, and it can support real-time applications. RF mesh has lower capacity and data rates compared to 3G, and its performance is highly dependent on the network configurations. In terms of PLC, it also has lower data rate. However, one of the key trade-offs is that the data rate depends a lot on the distance between the endpoints. Let's look at the next line, interference with other networks. 3G uses licensed spectrum and is protected from interference from other networks. RF mesh uses unlicensed spectrum, and that spectrum is shared by other products and technologies, for example, walkie-talkie. PLC operates in unshielded power cable, so it is, in some way, it should not be subject to interference. However, because the cables are not shielded, so it can also, in some cases, subject to interference from wireless and other systems. The last one, availability of other features. One of the advantages of 3G is that it has available voice and data services, and the utilities can leverage their existing service agreement to get voice and data services for their field operations. This table shows a comparison of some of the communications technologies in terms of the use case requirements. Let's look at them one at a time. First, 3G. 3G supports high data rate, low latency, and it also has a large network footprint. 3G networks are designed for, with reliability as a basic feature, and it is able to recover from unexpected disruptions. Because of all these and all the reasons we mentioned earlier, 3G is able to support the smart grid use case requirements. For RF mesh, one of the limitations is that it has relatively high latency. And for this reason, it is not a very suitable technology for distribution automation. In general, the performance of RF mesh is dependent on the network configuration. So very careful network design and engineering are needed in order to deliver the target performance and capabilities. For PLC, it is able to meet many of the smart grid use cases requirements. However, a firmware update might be challenging for PLC because of the high data rate requirements in order to deliver the firmware image. Also because PLC is dependent on the power line itself for communication, so it might in some cases have problems reporting power line outages. So this slide, this chart shows a total cost of ownership analysis that we have done. If you look at the legend on the right side, the total cost of ownership consists of both the OpEx and CapEx portions. The CapEx includes communication module and device cost, as well as network equipment and deployment cost. The OpEx includes connectivity, operation and management, data center usage, and other overhead costs. Without getting into all the detail, the key differentiating factor is that 3G incurs data connectivity costs to the network operator, and this is not required by the other two technologies. At the same time, this can be offset by the field operation and management cost that is high for RF mesh and PLC and is not required for 3G. So overall, 3G has the lowest total cost of ownership, and when taking performance into account, 3G delivers the highest performance and available data rate at the lowest cost. We concluded that the business case of 3G-enabled smart grid system can match or better than alternative solutions while delivering superior performance. Let me summarize some of the key points from this presentation. 3G networks provide an advanced and cost-effective solution for smart grid communications. 3G has a strong ecosystem that enables cost-effective deployment and operation. 3G is a mature technology that is supported by global standards. And there are available highly reliable services from the operators, and 3G today provides ubiquitous coverage. And finally, there are strong commitments from operators and vendors on smart grid applications.
Thank you, Joseph.